Let's write out the steps involved in this algorithm. Remember, for binary search algorithm to work, we need to make sure that the array is sorted. Then we are going to set the start and the end indexes. To begin with, the start index will be 0, indicating the first element in the array, and the end index will be the last index of the array, which is length of the array minus 1. Next, we need to loop. But we need to loop based on a condition. This means we are going to be using a while loop. What will be the condition that goes inside that while loop? We want to continue looping until the start and the end indexes do not cross. How do we know that the start and the end index have crossed? When the value of the start index becomes greater than the end index, this means that they have crossed each other. As long as the start index remains small or equal to the end index, we continue the loop. In the loop, we are going to calculate the midpoint index. The midpoint index is calculated by adding the start and the end index, and then dividing the result by 2. Remember that we are taking the quotient as the midpoint index. Using the midpoint index, we are going to compare to see if the number we are looking for is equal, greater, or less than the number at the midpoint index. If the element at the midpoint index is equal to the number to find, then our search is complete and we can return that index number. If the element at midpoint index is greater than the number to find, then we are going to discard the right half of the array and move the end index. Otherwise, if the element at the midpoint index is less than the number to find, then we are going to discard the left half of the array and move the start index. If our while loop ends, this means that the number we are looking for doesn't exist in the array. So we will return -1. Let's look at the pseudocode for this algorithm before we move on to coding this algorithm. In the beginning, I have a method called binary search. Remember from our previous steps, we are going to set the start and the end index. Start index will be 0. End index will be the length of the array -1, because that's going to give us the last index. Then we have our loop. Since we need a condition, we're going to be using a while loop. And the condition is going to be as long as the start index is smaller or equal to the end index, we're going to keep looping through our process. Inside the loop, we are going to be calculating the midpoint. The midpoint is going to be calculated by adding the start and the end index and then dividing it by 2. Then we have our 3 comparisons over here. We're going to check if the midpoint index that we found is equal to the number that we're looking for. The number that is at the midpoint index. You're going to compare the number at the midpoint index with the number that we are searching for. If they both match, this means we have found the element that we are looking for. It is present in the array, and then we are simply going to return the midpoint index. If that doesn't happen, we will go ahead and keep looping through, and then based on these conditions, if the midpoint is greater than the number that we are searching for, then we are going to move the end index. If the number at the midpoint is smaller than the number we are looking for, then we are going to simply move the starting index. Remember, if you're moving the end index, the new end index is going to be midpoint index -1. If we are moving the starting index, it's going to be the midpoint index +1. We continue this loop until either we find the item that we're looking for, or the while loop ends and the condition becomes false. In this case, we are simply going to come to the end and we are going to return -1. This is our basic pseudocode for binary search algorithm. In the next video, we'll take a look at how do we code this out in Eclipse.